we are looking at lesson 5.1.2, so we're solving equations now. We've been working on simplifying expressions, and we're still going to use a little bit of that simplifying, but now we're going to solve equations. So taking our algebraic steps to solve an equation, and just putting trig functions in place of the x's, basically. As we look at the first one, well, first of all, notice the directions say solve the following trigonometric equations over the interval 0 to 2 pi. And I'm not sure the homework reads exactly like that, but that's what I want you to do. Okay, all these we do, we're going to solve over the interval 0 to 2 pi, which means 0 to 2 pi is once around the unit circle. So we want all answers that make the equation true that are in that first time around the unit circle. Okay, I'll have to look at the book here at the end if I get a chance, but the book may give slightly different directions, but we're just doing on the interval 0 to 2 pi. Okay, so our first equation, sine x equals 1/2. There's not really solving to do in this one. We just have to know the answer. And let me state maybe the obvious. We are solving for x. So we want to know x equals what? Our goal on all the equations we do will be to get to this. This will kind of be the final point. You'll notice most of the equations are not this basic, right? But we want, instead of our x by itself, we want our trig function by itself. So we have sine x by itself. And my question to you is, at what angle does sine equal 1/2? So at what angle does sine equal 1/2? Pi over 6, correct? And where did he get that answer?
The chart.
From the chart, yes? So in quadrant 1, sine equals 1/2 at pi over 6. Now, do you notice he gave me radians? Do you notice radians is what I want? And I know I want radians because it said on the interval 0 to 2 pi. If it said on the interval 0 to 360, 360 degrees, then I'd look for degrees. But it did say 0 to 2 pi. Now, we're not done. I need another answer. In other words, there's often more than one answer today. So this is on the interval 0 to 2 pi. Are there other places that sine equals 1/2? Is there anything else on the chart? No. But notice on the chart, we only have angles from what quadrant? We only have angles from quadrant 1. Could sine equal 1/2 in another quadrant? It could. So I'm going to bring this back. Because here's the deal. We have to figure out what other quadrant we want to look at and figure out what angle in that quadrant makes sine equal 1/2. So we already used quadrant 1, yes? Because pi over 6 is in quadrant 1, so we already used that. What other quadrant do we need to look in? Quadrant 2? Why quadrant 2? Because 1/2 is a positive value, and we want to know when sine is positive. Down here, sine would be negative, sine would be negative. We'd have to talk about those quadrants if it wanted to know when is sine equal to negative 1/2, but we want positive 1/2. Okay, so at what angle, or I guess I should say, okay, so pi over 6 is the first quadrant angle. What is equivalent to pi over 6 in quadrant 2? Or what is pi over 6 up from the x-axis? 5 pi over 6. 5 pi over 6? So my other answer here is 5 pi over 6, because that is the quadrant 2 equivalency to pi over 6, right? So right here, I never wrote on this board this year, but here's pi over 6. We know we need quadrant 2, so what is pi over 6 up from the x-axis? And that is 5 pi over 6, right? Okay, you can always get that by doing pi minus 5 pi over 6 if that helps. So 6 pi over 6 minus 5 pi over 6, or excuse me, minus pi over 6. So one comment I'm going to put here is we want to make sure that we are checking the unit circle. How did I put it in here? Yeah. Checking the unit circle for the other values. Okay. So don't, honestly, more often than not, you have 2 or more answers today. On occasion, you have 1 answer, but more often than not, you have 2 or more answers. So be prepared for that. Okay. Don't just get 1 answer and say, oh, got it, moving on. You're going to cost yourself a lot of points that way. Okay, questions I can explain on that one. Because that's the basics. We've got to get the basics before we can move on to the not so much basics. Okay, let's look at equation 2. Equation 2, cosine x plus 1 equals 0. Well, normally our job is to get x by itself. What's our job going to be this time? We're not getting x by itself, but we're getting cosine x by itself. How do I get cosine x by itself? If it's cosine x plus 1, we're going to subtract 1. If I subtract 1 on the left, I'm subtracting 1 on the right. So what does my equation read now? We have cosine x by itself. 0 minus 1 is negative 1. Now that I have my trig function by itself, I'm ready to ask myself, at what angle does cosine equal negative 1? Now, if you start on the chart, when does cosine, and I wouldn't even worry about the negative at this point, but when does cosine equal 1, according to my chart? It's not listed, is it? So it's not at pi over 6, pi over 4, pi over 3. What do we need to think about here? If it's not one of those first quadrant angles, when do those zeros and ones often happen? At our quadrantal angles, right? So you're more likely thinking, okay, is it at 0? Is it at pi over 2? Is it at pi? Is it at 3 pi over 2? Does this sound familiar? How do we think through this here?
Causes the x value anywhere it occurs.
Okay, correct. Cosine is x value. So we're looking for the x value of negative 1. And as we think through these, right, here's 1, 0. Here's 0, 1. Negative 1, 0. And 0, negative 1. So at what angle does cosine equal negative 1? And that's happening here at pi. Does it happen at a second angle? And it does not. So in this case, you just have one answer. Cosine x will equal negative 1 at pi. Now, if we were asking where cosine would equal 0, then we'd have 2 answers. But since it was -1, there was just one answer. Okay. Let me know if you have questions. What can I answer to explain better? Otherwise, I'm just going to keep moving. Okay, example 3. Told you we got to get the basics, right? Now we're ready to go a little more complicated here. Thoughts on cosine squared x plus cosine x minus 2 equals 0.
Move the 2 to the right side and then factor cosine.
Not quite. I do like the word factoring in there. I do like the word factoring. We can't factor just an x out because x is attached to cosine.
So just factor the cosine.
Would you just factor the whole left side of the equation?
Yeah. Can you guys see what this reminds you of algebraically? So what if I drop those cosines out for a moment? Do you see it, Miles?
Do you have to do, you have to separate the, so you have to get the 2 on the right side and then, I don't know. I don't know how to explain it.
I don't want to move the 2.
It's the one thing.
Yeah,
One
what do you
You
get?
get the 2 parentheses. Whatever. It's completing the square.
That's
No.
what,
No, 2 parentheses. Think product and sum.
Yes.
We're going to think product and sum. Now, I know some of you are saying, what? I see cosines. You can't talk product and sum. But here's what I'm going to say, and I'm going to write this up above. I want you to think, instead of thinking cosine squared x, I'm just going to have you think x squared. Instead of cosine x, just think x. Minus 2 equals 0. If I give you the equation, x squared plus x minus 2 equals 0. Because there were no numbers here, right? This is just a 1 cosine squared x and a 1 cosine x minus 2. If we drop those cosines out for a moment, can you solve that? Can you factor? 2 parentheses, right? I'm going to factor this here, and then we'll go back to the real problem. X squared breaks into x and x. What multiplies to be -2 and adds to be 1.
2 and then,
Yep. 2 and -1. I processed 1 and 2. I hadn't processed my signs yet. Okay, you can factor that, yes? Okay. Now we're going to do it with cosines. So, and this is why I said I don't want to move the 2 over, because I'm seeing a squared term, a regular term, and a number term. So I want that equal to 0 so I can factor it. Now, okay, cosine squared x. See, x squared broke into x times x. So what's cosine squared x break into? Cosine x times cosine x. What were my numbers that multiplied to be -2 and added to be 1? It was -1 and +2. So we're using those algebra skills, but we're using trig with. What's the next step? 2 parentheses multiplied equals 0. We're going to set each part equal to 0. Cosine x minus 1 equals 0. Or cosine x plus 2 equals 0. Just like what you would have done up here, right? We would have set x minus 1 equals 0, x plus 2 equals 0. when I set cosine x minus 1 equals 0 and cosine x plus 2 equals 0. And now we can solve. If it's cosine x minus 1, you're going to add 1 over, correct? So cosine x equals 1. Or if it's cosine x plus 2, subtract 2 over, and cosine x equals negative 2. So we have 2 questions to ask ourselves. Let's start with the first. At what angle does cosine equal 1? At what angle does cosine equal 1? You can go back up here on our last problem if you want to use that picture. Where does cosine equal 1? At the angle of 0, yes? So an answer is x equals 0. Use 0, not 2 pi. Because notice my interval is, oh, my interval is a typo. It should say 0 to 2 pi, and 2 pi should be a parenthesis. I didn't realize it wasn't a parenthesis there. Okay, so at 0 degrees, or 0 radians, is an answer. When does cosine equal negative 2? At what angle does cosine equal negative 2? At pi, cosine equals negative 1.
If it goes around twice, it's negative 2.
Nope. If it goes around twice, it's still negative 1. I wondered why you said that. Okay, now I'm following. I got it. Think about your cosine curve. When does cosine go to a level of negative 2? What's a typical cosine curve do?
Negative 1.
Typical cosine curve, if it's not stretched or anything, goes up and down between 1 and negative 1. Does it ever go down to negative 2? Not a typical cosine curve. This answer is not possible. If that was our only part of the problem, we'd say no solution. So this answer is not possible. However, do we still have our other answer? We do. So what that means is our only answer is 0. Okay? Ready for example 4? You guys are quiet. I'm not sure how you're taking this. I don't know if it's good or bad here, or we're still just trying to process. Okay. Question 4. 2 sine squared x plus sine x minus 1 equals 0. What are you noticing here?
You can factor that too.
Yeah.
Has it too.
Yeah, there's an extra tricky step, but yeah. Is this a quadratic equal to 0 again? Kind of like what we had over here, right? It's a quadratic equal to 0. Now, as we get better about this, you may not need this think step. But for the moment, I'm going to put this think step in. If I drop those signs out for you, 2 sine squared x is saying 2x squared. Plus sine x, well, that's saying plus 1 sine x. So plus x minus 1 equals 0. Now, as Craig pointed out, there is a 2. Technically, if there's a 2 out front, I could possibly be taking you guys through product of AC, couldn't I? But I'll be honest, you don't need product of AC for this one. Just think logically with me. Give me a chance here. What do you know about 2x squared? What does 2x squared have to break up into?
X squared.
Not x squared. 2x and x. Kind of like here, x squared breaks into x times x. 2x squared is going to break into 2x and 1x. That's my only option for 2x squared when we're factoring product and sum, right? What about down here? What's 1 have to break up into? The only option for 1 is 1 times 1. In other words, I'm kind of forcing you guys to do guess and check here. I don't know that I'm forcing, but I'm just not wasting my time on product of AC here. Now, if it multiplies to be -1, what do you know about one of those ones? It has to be negative, correct? Now, all that matters, just make it happen so you're going to end up with a positive x in your middle terms. So when you multiply your outers and your inners, we want to end up with a positive x. So what I'm saying here is I want 2x, my outsides, 2x times 1 to be positive. And I want my insides, 1 times x, to be negative. That way I'll be able to do positive 2x minus 1x. Foil that back together as your practice if you're not sure about that. Okay? But that's our factoring. Product of AC if you prefer. Now, are we ready to do our actual problem? We're going to factor this into, instead of 2x minus 1, I'm going to say 2 sine x minus 1. Instead of x plus 1, I'm going to say sine x plus 1. Two parentheses, multiplying to equal 0, we're going to set each part equal to 0. So 2 sine x minus 1 equals 0, or sine x plus 1 equals 0. Yeah?
Can we go over the signs again?
How I got minus and plus here? Okay. Basically how I got minus and plus is I was kind of just foiling in my head, if you will. I mean, I know right here 2x times x is going to be my 2x squared. And I know that I need this guy to be a positive 1x. So if I'm going to multiply 2x times 1 here, that's going to get 2x. If I'm going to multiply 1 times x here, I'm going to get 1x. How am I going to get my 2x and my 1x to become a positive 1x right there? That's what I was asking myself. In other words, where do I need to put my minus? Knowing that I need my two end pieces to multiply to be -1 for here, that's why I was kind of asking myself, okay, I can either make it -1 plus 1 or +1 minus 1. And because I want my middles to give me a positive 1x, I could come up with, okay, I need a positive 2x and a minus 1x. Does that make sense? And basically, I kind of foiled it in my head is what I did. Maybe, maybe not. If you're really not liking that, go back and think product of AC.
Well, I did, and -1 of 1 doesn't equal 1.
-1 times 1.
Yeah, but 1 is still the sum, right? 1x, and then if it's product of AC, it's multiplied by 2x.
So for the product, you're doing a product of -2.
Yeah, and the sum is still 1.
Right. But then you don't just put those numbers here. You have to then split your middle term. Is that the part you're forgetting?
Well, yeah.
Because like if I was trying to factor that, I have to split my middle term. So product of -2 and a sum of 1 is what? A 2x, a 2 and a -1? Right? So I split that, bring down the 2x squared, and bring down the minus 1. Does that sound familiar? Brief product of AC review there. GCF of the first half is 2x, ending up with x plus 1. GCF of the back half is a minus 1, ending up with x plus 1. And so then I have my 2x minus 1 and my x plus 1. Okay, product of AC still works. I try and push you guys as pre-cal students to sometimes process through it without product of AC when the numbers are easy. You guys don't always like me for it, but okay, are we better now? One way or another, you can factor that. Okay. So instead of x's, I'd put sine x's back in, right? So I have 2 sine x minus 1 equals 0, sine x plus 1 equals 0, because I set each part equal to 0. 2 sine x minus 1 equals 0. How do I get sine x by itself? First, we're going to have to add the 1 over. Yep. So if I add the 1 over, I then end up with 2 sine x equals 1. Is sine x by itself? No, it's 2 sine x. How do I get sine x by itself? We're going to divide by 2. So we're going to be asking ourselves, where does sine x equal 1/2? We also, over here, if it's sine x plus 1 equals 0, we're going to have to subtract 1. And we're going to be asking, where does sine equal -1? Don't stop, though. I want to know x, right? I don't want to know sine x. I want to know x. At what angles, or at what angle to start with, does sine equal 1/2? Pi over 6. That's my first quadrant angle, yes, and this is positive, so we want that. Is there another answer where sine equals 1/2? 5 pi over 6? Can we cheat off ourselves and steal our previous answers?
Yep.
Yes, that is the one type of cheating I will accept. You can cheat off yourself and steal your previous answers. Hopefully you got them right the previous time, right? Remember, it was 1 else is sine positive. Sine was positive in quadrant 2. The pi over 6 angle is 5 pi over 6. Okay, we have 2 answers. Now we got to ask about sine x equals -1. At what angle does sine equal -1?
3 pi over 2.
3 pi over 2? Remember, we're not going to find sine equals -1 on our chart, are we? But, go back to my picture I drew up here, right? When does sine equal -1? When is my y value -1? And that is at 3 pi over 2. Does sine equal -1 again? And no, because it's +1 up there and the other 2 are 0. So I ended up with 3 answers this time. Okay. Again, you can have as few as 1 answer. You can have 2, 3, 4. You might even have like 6 answers at times in homework. It does happen. So you're always checking for all answers. Questions here? Okay, try another one. I do want / feel the need to go through all of these because they all have a little bit different pieces to them. 5 and 6, definitely want to go through those. 7 and 8 are a little different. You don't see as much of those in homework, but we do need to talk about them. So number 5. 3 tangent squared x minus secant squared x minus 5 equals 0. Thoughts? things you're noticing? What's different about this problem? My last problems, 3 was all in terms of cosine. 4 was all in terms of sine. What about this one?
It's not the same.
We don't get all the same function. Makes it hard to do any solving or factoring steps, because this is like saying 3x, this is in a way 3x squared minus y squared minus 5. When you've got 2 different trig functions, you almost have 2 different variables. I preferably would like to have all one variable. AKA, I'd like to have all one trig function. Thoughts of how I could get all one trig function here? And do note, I did say those identities we were learning at the beginning of lesson 5.1, I said they weren't going away, right?
Determine the sine and cosine.
I'm still going to have 2 trig functions then. Huh? Is what one? You're going to the right identity. You're just,
It's gotta be 1.
well,
Well, no. Is it -1?
not exactly. So what identity are you trying to use here?
The Pythagorean theorem.
Yeah, or Pythagorean identity, right? One of the Pythagorean identities, it connects tangent squared and secant squared. And here's the idea. That is 3 tangent squared minus secant squared. So we can't replace both of them. Well, for one, our variables would be gone. But can I replace one of these? Can I just replace just the tangent or just the secant with what it's equal to? What's the Pythagorean identity? It's, I'm trying to remember how it reads in the book. Does it say 1 plus tangent squared equals secant squared? Here's what I'm going to go with. I see a secant squared here. And I'm choosing to go that way so I can just work with tangents. You could do this the other way too, but this one's kind of already set up. So what can I replace secant squared x with? 1 plus tangent squared x. So here's what I'm going to do. I'm going to recopy my equation. We're still going to have 3 tangent squared x minus, what am I putting in for secant squared x? And that is 1 plus tangent squared x. There's still minus 5, and it still equals 0. And this is because there is a PI, a Pythagorean identity, that works to my advantage. I didn't leave myself enough room to write that up there. So look for those Pythagorean identities that connect the two, can connect the two. Okay? Since my problem was in terms of tangent and secant, there's the Pythagorean identity that connects them. I can go to all tangent or all secant. Tangent to me seems the more logical here. A, because I think I'd rather work with tangent than secant. But B, my identity was set up 1 plus tangent squared equals secant squared. Okay. Notice I put it in parentheses, yes? I put in parentheses specifically because it was being subtracted. So if you will, I'm going to kind of distribute the subtraction sign and rewrite this without parentheses. 3 tangent squared x. It's going to be minus 1 minus tangent squared x minus 5 equals 0. So So all I did is just rewrote it without the parentheses, subtracting both the 1 and the tangent squared. Okay. Think like an algebraic equation. What do you see here? Like terms? Put your like terms together. What is 3 tangent squared x minus tangent squared x? 2 tangent squared x. 3 of something minus 1 of something is 2 tangent squared x. And then we also have constants there that are like, right? Minus 1 and minus 5 is going to go together as minus 6. So when I clean up those like terms, I now have 2 tangent squared x minus 6 equals 0. And if you're looking for the, okay, what do I do? I'm going to erase this, but here's the deal. Drop out the tangent in your brain for a moment. Ask yourself, how do you solve 2x squared minus 6 equals 0? Add the 6 over, right? There's only x squared, so this is not product and sum. This is get the x squared by itself. So if I add the 6 over, then I end up with 2 tangent x squared equals 6. You need the visual over here, right? And again, I'm going to erase that. I'm not going to leave it there because I'm into another problem, but that's 2x squared equals 6, right? Now what's your algebra brain tell you to do? We're going to divide by 2. So if we divide by 2, I'm now going to have tangent x squared equals, or tangent squared x equals 3. Now what? Square root, yes? Okay, I'm going to get rid of this. If we have to square root the left, we're going to square root the right. So what's the square root of tangent squared x? And that's tangent x. What's the square root of 3? And? Negative square root of 3? Oh, are we in an equation setting? Should we say plus or minus? We should. Whoops, I forgot something important there. There we go. So tangent x equals plus or minus the square root of 3. So what are we asking ourselves here? And I'm going to have to come up here a little bit. We want to know, when does tangent equal positive square root of 3? And when does tangent equal negative square root of 3? Okay. What did you figure out? I already saw you guys looking at the sideboard. When does tangent equal square root of 3? That is down at pi over 3, right?
3, yeah, that's what I meant.
You made me double check myself. I was like, oh no, who made the mistake here? I'm as bad as you guys. I can get my 6s and 3s confused real quickly, so it doesn't take much. Now, are you guys realizing how many answers we're going to have here? Can you process 4 answers? Because what happens? There are 2 quadrants where tangent is positive, right? And then what about the other 2 quadrants? Tangent is negative. So basically we need the answer for every quadrant. Up here, it was pi over 3. Well, we can just go in order if you want. Over here in quadrant 2, what is my pi over 3 angle? What is pi over 3 up from the x-axis? And that's going to be what? 2 pi over 3. Quadrant 3. This is my other positive angle, right? This is where tangent is going to be positive. What is pi over 3 down from the x-axis? And that's going to be 4 pi over 3. And quadrant 4. My other negative tangent, what is pi over 3 down from the x-axis? 5 pi over 3. Definitely had 4 answers there. Because for the positive we had 2, and for the negative we had 2. Yeah, I ran into 6 a little bit. I should have scooted that over some, but. Okay. That's a good stopping place. We definitely need to tackle number 6 tomorrow. And then we will also look at 7 and 8. You have an idea of what you're doing. My plan for tomorrow is those 3 examples and then some work time. You are welcome to go ahead and start looking at the homework tonight. You'll have an idea of how to do some of these. You've seen a lot of the basics. You'll have an idea. Now, there's some you're not ready for, obviously, but you're welcome to go ahead and start looking at some of them and try them. And then tomorrow we'll have, hopefully, some work time, and if you have questions, we can start looking at those. Okay? But I guess it does make the homework due on Monday. I was hoping we could have it due tomorrow, but not quite. We didn't get through enough examples.